Welcome, everyone. My name is Enrico. You can get in touch with me on my Twitter account. That's my blog. Thanks for the introduction. I don't know if I'm that absolutely technical, rather good, but you can read my blog there. And the slides are already on my Slasher account, so you can look them up there. I'm a principal software engineer for Pivotal Labs, a agile software consultancy in Boulder, Colorado. Pivotal has offices in major city and has now got an office in Sydney, down south. Let me start by saying that there is no special tool or silver bullet that will allow you to build and maintain large Ruby applications. So I'm not going to come up with a gem that fixes all your problems. And this is not about application with large loads, but rather with large business rules. Complex domains evolving as the application development goes on. And you might have heard that Ruby shouldn't be used in large applications. And in my experience, large Ruby application poses challenges, but they are possible with a combination of three factors: team diligence, the use of local Ruby gems, and automated testing. Those elements alone, in my experience, were not sufficient. Local gems alone was not sufficient. Team diligence alone was not sufficient. And automated testing alone was not sufficient. The result was an application that you want to work on, an application that you can understand on day one, rather than being overwhelmed with cognitive overload and details that makes you run away from it. If by now you're wondering where my accent is from, I'm Italian. I learned to speak English watching Family Guy. I lived in Australia, in Sydney, for about 6.5 years, and now in the United States for 2. So my accent will fluctuate in those 4 regions during the talk. Ruby files in a project are like ingredients in a recipe. Think the project that you're working on right now. Can you tell what recipes it's cooking? Would a new developer be able to do that? Now imagine your project in 6 months from now. Would you still be able to tell what recipes it's cooking? Would a new developer be able to do that? Can you tell what those ingredients are for? Those are the ingredients for piadina. Piadina is a popular street snack in Italy, priced between 3 to 5 euros. But in Sydney, Australia, it can only be found in one little cafe opened by 2 young Italians near Bondi Beach, priced for the equivalent of 10 to 12 euros. So one simple dish, one simple recipe can be extremely profitable. Now, this is inspired by real facts, so I'm going to make up names. I'm going to call the 2 owners Mario and Luigi. Mario and Luigi are from Brescia, a province in Italy that is not particularly famous for their piadina, but it's the only place in Sydney that does it, so when me and my friends wanted to have it, we had to go there. Now, every time we went there, we never saw Mario or Luigi making piadinas. They had a couple of students, Stevo and Anna, and they had no cooking experience, but they learned the recipe, familiarized themselves with the ingredients, and started making the profitable piadina for Mario and Luigi. Everything was working out fine until 3 months later, when I speak with Mario, Anna went on a gap year. And so he had to ask someone else, Diego, another student with no cooking experience. And as he looked at the ingredients, he had no idea what was going on. He needed Stevo's help. And that's some intrinsic difficulty in learning something new. Mario was annoyed. He was muttering and shouting at him in Italian. So he said, Diego, sei lento, smettila, fai qualcosa. But that's normal. And after a few days, everything went back to normal. Until 6 months later, Mario and Luigi realized that selling piadina isn't as profitable as it once was, and they bring in new recipes onto the menu. Pizza, tiramisu, carrot cake. And with them, the ingredients. Now, would you be able to tell the recipes for the ingredients for the new recipe? You can probably find one for carrot cake, but you might be struggling to find the rest. And you still find the ingredients for piadina? Stevo's reaction to this was a mix of confusion and frustration. He was now not just affected by the intrinsic difficulty of learning new recipe. There is also an extraneous difficulty, an extraneous load about this kitchen worktop. But he's a novice to this. He's thinking, maybe there's something wrong with me. Because to Mario and Luigi, it's pretty clear. There are 4 recipes on the kitchen worktop. And then he starts thinking, perhaps the kitchen worktop is not organized very well. And he speaks with Mario, shouldn't we organize this somehow? And Mario goes, for sure, everyone in Italy groups ingredients by color. And so the following the ingredients are grouped by color. And that's not helping at all. When Mario orders a pizza, now Steve always needs to think, which ingredient is red in pizza, which ingredient is white? And when he complains with Mario, he replies, well, this is the convention in Italy. Have you ever seen this happening in a Ruby application? Now, classes grouped by design pattern is okay in a tiny app, but in larger application, it gets in the way of navigating your code. Classes grouped by design pattern, it describes a trait about that class, but it says nothing about its operational context. So the following day, Steve, with his confidence and the help of Mario, divide the kitchen worktop in 4 areas for the 4 recipes. And yes, there are some shared ingredients, but it's pretty clear which one they are, and it doesn't get in the way of cooking. So everything is working out fine, and one day, Steve is preparing carrot cake, and Diego is sitting next to him preparing pizza. But Steve is rushing. He wants to go down Bondi, play volleyball with his friends, and as he's reaching for the milk jar, it slips off his big hands and cracks open onto the kitchen worktop, spoiling the tiramisu cream, the pizza dough. And Mario goes, "Ma no, ma no," which translates to, "Oh no, oh no." This is similar to the use of namespaces in Ruby. They provide a simple form of separation for your application. They create a little boundary. Classes defined within a namespace are specific to that context and force all their external clients to use the full namespace to access them. In this example, the submission class defined within promotions is accessing a finder class defined within membership. And that's a dependency there between the promotions and the membership. And that's a dependency that you won't find out unless you read the whole code, which is fine in a small application. But how does that work out in a bigger app? I worked on this application for about 3 years in a team of 5. And we started with namespaces. We divided vertical slices of it. We created silos so that developers were working in parallel. And it was working out fine at the beginning. But after about 1 year, we realized we created a cross-namespace tangle of dependencies. Those silos were leaking into each other. It was difficult to onboard new developers. At the center of the tangle, files that when changed were like causing side effects, unwanted side effects. People were laughing at us when we were worried about this. And in the end, this became the application nobody wanted to touch. There was a desire to fix the problem, but we could not commit to team-wide diligent work. And some people were saying, well, this is the Ruby way. Is it? I don't think so. Ruby gives us a tool to build maintainable application, and we'll see that in a moment. Stevo, Mario, Luigi, and Diego agreed to separate each recipe on its own kitchen worktop. Now, any leakage or any problem will be contained within that space. And there's a shared area where shared ingredients are left. Now, what is preventing that shared workspace from becoming a mess? It's team diligence. This is similar to the use of local Ruby gems. Now, you might be familiar with rubygems.org, where you pull and push open source libraries. But there's a misconception that that's all gems can do, the reusable functionality that you push or pull to a public or private server. But that's wrong. You can have gems local to your repository, local to your application, used as the building blocks, as the solid dependency structure of your app, an intention-revealing dependency structure. Everything starts from one little gem that contains everything that is your first feature. And as you get new functionality, you will extract that shared functionality into another gem. Now, each gem has a specification file a map that guides you through your large application. That's how you reduce the cognitive overload. That's how you think of your application in smaller chunks. When you have tiramisu and carrot cake, you might be thinking, do I need 2 gems or 1? And that screen went offline. And it came back. So it's up to you to decide those boundaries. And it's offline again. And it's online. OK, I'm going to say this area, just in case it's me. So as you get new features, as Mario asks for a calzone, which is a folded pizza, you extract the pizza dough out of pizza and share it with the calzone. The objective here is to create an intention-revealing dependency structure that maps your application boundaries, something that you can communicate with your product owner or within your team. But the risk is to create a dependency structure that is purely technical, that gets in the way of this communication. So my general rule is to have between 2 to 3 concepts within each gem. And when I have more than that, I ask my product owner, is this a different context? Is a different team or a different company operating at the other end of this feature? And Conway's law helps us defining those boundaries. All the dependencies go from the top to the bottom. The main application doesn't have behavior. It just depends on those gems. And dependency don't go from the bottom to the top. Otherwise, they'll create circular dependency, and you'll be warned about that by gem. Now, for the next 4 minutes, we will get into technical detail of how to build a local dependency structure. Code and examples are online on my blog post. If I lose you at any point, grab me after the talk. I'll try and clarify that. The main Ruby application can be any framework. The main Ruby application is a delivery mechanism for your business logic, which is encapsulated within gems. In this application that we were working on, we had multiple files, each with one responsibility, helping out this class doing its job. In this example, you only see 2 files connecting to each other. And the Ruby application is just a script that calls the health plan aggregator class. And we will connect the health plan gem to your drug information gem from the main application. So the main application is just calling health plan aggregator and requiring that gem. Now, the gem file that you might be used to has an option called path that tells it those gems are local to your repository. And that's the only gem the main application is worried about, the entry point. All the transient dependency will be dragged in automatically. Within that directory, local gems, that you should call something meaningful to your team. I often call it components. You can create a gem with bundle. I often use bundle gem. That also creates a repository that you want to remove because the gem will live within the main application repository. Now, the health plan gem has a specification file. And it went offline. And it's back. And the specification file has a line for development dependency where you install a spec locked to a specific version so that multiple gems won't install different versions of it. And now you can write your spec, and this is just an example. It's just ensuring that the details method returns a hash. Now this will fail. We need to add the health and aggregator, and that's different if you're used from Rails auto-loading things. So within gems, you need to manually require files. And then we can write our aggregator class. The test will now be passing. The Ruby application, the main Ruby app, is connected to the first gem. Let's connect the first gem to the other dependency. So we create it. And then within the aggregator, we just stop that drug information fetcher class. This will now error because there is no drug information within health plan at the moment. So now we add the dependency from health plan to drug information. And next, an important step is to add the path with the parent directory. That says those gems that you will find are within this directory. Otherwise, drug information will be looked up on rubygems.org. And the gem spec says there are gems that you should install from the specification file we just looked at. Now, next, you must require that gem within the health plan entry point, and then you can leverage it. This is a simplified example, but there's more details on my blog post. And bundle come with a viz option that allows you to visualize dependencies in gems, so that's handy. And there is an option for that in specific for Rails on that link. Now, I said automated testing is critical to this strategy. That's because each gem needs to be unit tested in isolation in order to ensure that the dependency is solid. If E, for example, breaks its dependency, accessing D, the unit test will tell you about that. But this might not be a problem when everything is loaded in memory. Let's see this example. So we have a Ruby application, something loaded in memory, and there are two gems, gem A and B. Gem A requires and uses C. Gem B uses C but does not require it. When you fire up your app and access behavior within gem B, there's going to be an error. I don't know what gem C is about. But if you fire up your app, access gem A now requires gem C. Everything is fine. What happens if you now access gem B? There's not going to be any error. Those flaky bugs are really hard to debug, and that's why you must unit test if you want to follow this strategy. And that's why team diligence is so important, because there is a million ways to bypass those tests. The application was about like health insurance, and we were fetching different information, and we were able to extract some common behavior to fetch claims into a gem. That gem was then leveraged when a membership payment functionality came in. This is a modular monolith. Each of those areas were contexts that we could talk about. If something changed within the payment platform, we could go within that gem rather than within membership payment between line 850 and 962. It was easy to think about those boundaries. As your team grows, you can assign an A team to your A feature, and you can assign an F team to your other feature. But now, what happens to the code that stands in the middle? Well, that's a responsibility of the whole team. That's why team diligence is so important. And what happens if those three drones that work with the young teenager and the old bloke turn out to be Joker, Darth Vader, and Terminator? And they find your use of gems disturbing. They don't like it at all. Well, in a team of between 6 and 10 people, you should be able to have some team diligence. You can probably find out what's bothering them. Perhaps they've been burned by gems and engines. It's quite possible. Perhaps they are okay giving it another try as an experiment. They can elaborate what went wrong for them. Or perhaps there's just something else that they can do within your company, another project they can temporarily work for. Joker can be director of happiness, and Terminator, director of security, should work out pretty well. But this brings up a good point. How is team diligence working out when the team becomes bigger? As you have more people, those in-process boundaries that you create are going to be more difficult to maintain. That's the moment that you might think that slices of your monolith can be moved to a service. But you want to wait until the last responsible moment. You don't want to move too early. The story of how this team moves to services for another talk. But I wrote a blog post about prematurely moving to services in a team of 4 and the downsides that it brought in. How would this application with this dependency structure look just with namespaces? It will look like this. The dependencies between those namespaces are still there, but you can't see them anymore. That's the monolith that I want to try to avoid. That's the monolith that motivated me to do this talk. Using local gems allowed us to deploy parts of a monolithic application. I wrote a blog post that gets into the detail. But we had this app. We were a team of 4. And it started as a monolithic app. It had 2 sections, like an admin portion for editorials and a public portion. And about 3 months into development, we were told that the admin portion had to be deployed within a company VPN. And so someone suggested perhaps we should re-architect this with services. An admin application and a public application speaking with an API. But it felt kind of over-engineered. And instead of doing that, we divided those boundaries within the application. So the editorial administration and the public content had some shared behavior. The editorial administration was speaking with this persistence layer that was the only one speaking with the database, with a very clear interface. The editorial administration had a behavior. A very thin service layer was there. When something was persisted, it would be published into this size search system. So this gem was encapsulating sending out messages to this other system. And it was sharing some user interface with the public, so that previewed content looked like on the public side of it. And public was doing similar things. It was accessing the persistence layer through the same interfaces. And we had running modes that was telling the application what to run. So when the admin mode was set to admin, only the admin dependency structure was loaded. Only the admin routes were loaded. And when it was set to public, on the public server, it would only load the public dependency structure. Another interesting thing that we did was running a legacy migration. We had all those scripts that had to be put somewhere. We had a migration process that was ongoing for months before we was going live. And we knew we wanted to put those files somewhere that were not tainting the persistence layer. We didn't want to go live and then have to scrape back all those scripts or all those changes. And so where to put them? We encapsulated all the logic to pull legacy content out of the nasty legacy system. There you go. I think it's when I put something. Oh, there you go. Back. I think it's that star. It's turning it off. So all that was encapsulated within this gem. And once we decided to go live, we just removed that gem. And there was little trace behind about the migration. Now, within a Rails application, those high-level editorial and public, those high-level entry points must be engines. Engines are gems that plug in routes and controllers within a Rails application. But what doesn't need to interact with the framework, like the size search, was a gem. Now, your application might be a Piadina today, but how likely is it to stay that way? Instead of piling up ingredients on one kitchen worktop, start thinking in terms of separate contexts. When you go back to your application, start thinking about local gems, but be aware of a team in a fixed mindset. A team in a fixed mindset will believe their skills and abilities are set. You either have it or you don't. And failing definitely means you don't. So they will think of local gems as something that they're not smart enough to work with. Or the opposite, they are too smart to work with local gems. There's just a hack, not the Ruby way. So perhaps a team in a fixed mindset will not take on new challenges. They rather keep doing what they know well, because that way they can keep being safe, keep being smart, or looking smart. So in such a team, if you're introducing this in such a team, try and introduce local gems as an experiment in a little area of your application. And when you refer to your work on it, rather than saying you need to be talented or smart to use gems, you just need to have a little bit of experience, a little bit of hard work. And rather than saying that person never understands JavaScript, never understands Ruby gems, or always writes a maintainable code. Well, it doesn't write maintainable code yet. It doesn't understand Ruby gems yet. So embrace the power of yet. So once you go back to your team, ensure that they're OK with an experiment about local gems or a wider strategy. And then start finding those boundaries. Introduce your next feature or move part of your current feature within a Ruby gem. And then from there, start tracking bugs and feature velocity so that you can compare the area that is modularized against the rest and use that as a way to demonstrate this strategy to skepticals in your team. And don't forget to write automated testing to ensure your dependency structure is solid. I believe this strategy will help you as much as it helped me build and maintain large Ruby applications. I'll be around for questions. Thank you.
All right. So do we have any questions for Enrico? Yep. All right.
Thank you, Enrico. Just wondering about how you split things like models and services and things like that. Is there a pattern that you follow?
So, everyone heard the question? Yes, it was broadcasted. Yes, cool. So the models, so the pattern that you follow, that's one thing I forgot to say. Within those dependency structure, you follow whichever best object-oriented pattern you want to follow. But usually, the models are all encapsulated. We sometimes had some success sticking with active record. Sometimes we had to be more creative. The high-level entry points would never have any migration or any knowledge about the database. They will only have that thin layer.
All right, cool. We probably need to move on to the next talk. So
All right.
thank you so much.
Thank you.